In this video, I'm going to go through tricks to memorizing the unit circle. Now, in order to do this, there's a couple things we have to kind of review just to kind of start off. So real quick, I'm just going to kind of refresh our memory of a concept called reference angles. So reference angle is an angle that our line makes with the closest part of the x-axis. So right here, this would be a reference angle for that ray. The angle that we're given is going to be this angle right here, okay? But the reference angle, this green angle, is the angle that is easier to work with simply because it's less than 90 degrees, okay? So like, for instance, the angle, if this red angle happened to be 150, that means the reference angle is 30 degrees. That's how the reference angles work. So in, like, let's say we have an angle in, oops, here, actually, let me try to be more clever than that. Let's say we have an angle in the fourth quadrant, okay, like that. So like, let's say this is 7 pi fourths, something like that. The reference angle is this angle right here. From that line, the closest angle that it makes with the x-axis. So since the whole thing is 2 pi, in order to total up to 2 pi, this would be pi fourths. That's that reference angle. Okay. So first thing you do need to kind of work on is switching between radians and degrees. And really, it starts to become easier as you practice it, okay? But you can always use the conversion. In other words, you can always convert from degrees, like if you're given some sort of degrees, by multiplying by pi over 180 degrees, okay? That cancels the degrees out, and you're left with your angle in radians, okay? So if you have trouble, you can always convert. There's nothing wrong with that. But it is useful to start kind of memorizing. Now, really what I have focused on memorizing on the unit circle is the first quadrant. And I don't even have it completely memorized. What I have memorized in the first quadrant are the angles and their degrees versus radians. That's what I have memorized. Okay, so let me just focus in on the first quadrant then. Here's my unit circle. Okay, so right here is obviously the angle 0 degrees or 0 radians. It's 0 for both. Okay. It also, when you go around completely, it becomes 360 or 2 pi. Okay. Right here is the angle 90 degrees or pi halves. Great. All right. The halfway mark is the next easiest angle, and that would be 45 degrees or pi fourths. Half of pi half, right? Taking half of pi halves, that's what that's doing. And taking half of a fraction means that you are just simply multiplying the denominator by 2. Okay. Oh, my screen froze for a second. Why is it freezing? Who knows? Maybe it'll eventually come back. There we go. Okay. Okay, the other two angles are the ones we kind of have to remember. So there's one that's closer to 0 and one that's closer to 90 degrees or pi halves. Okay, the one that's closer to 0 is 30 degrees. And then this one right here is 60 degrees. Okay, and then of course, noticing that this is 30 degrees, 30 degrees, 30 degrees. Okay, but that's consistent. Okay, so for radians, the smaller fraction is the one with the bigger denominator, and that's pi sixth. The bigger fraction is the one with the smaller denominator, which is pi thirds. Okay. And in the same pattern that the degrees go by 30 degrees, each of these breaks are pi over 6. So this is pi over 6 from here to here. From here to here is another pi over 6, or 2 pi over 6, which reduces to pi thirds. And then another pi over 6 here is 3 pi over 6, which reduces to pi 6. So that's something I have memorized and I know and I understand. Okay, the other piece I memorize are the values that sine and cosine take on for the unit circle. Okay, and it's one of 5 values. It's either going to be 0, 1/2, radical 2 over 2, radical 3 over 2, or 1. Okay, now real quick comment. This is a pattern in and of itself. You can write all 5 of these numbers in the similar fashion. The first number would be the square root of 0 over 2. The second number would be the square root of 1 over 2. Third number is square root of 2 over 2. Fourth number is square root of 3 over 2. And the fifth number is square root of 4 over 2. They all follow that pattern of just increasing the numerator by 1 under the square root. But the ones that reduce, namely 0 reduces, that 1 under the square root just becomes a 1. And then the square root of 4 is a 2, which when we divide by 2 comes out to 1. So all of those values reduce down to the 5 values we need to remember for the unit circle. Okay, and those are the big values we have to know. Now, 0 and 1 are easiest to identify because they're always on the X or Y axis. Okay, of course, they can take on positives and negatives depending on where we're at, but those are the easiest. It's the 3 in the middle. Now, again, the middlemost is the next easiest to remember because it is assigned to the pi fourths or 45-degree angle. Okay, so at this angle, both sine and cosine are square root of 2 over 2. Here we have 1, 0, and then here we have 0, 1. Okay, easiest ones to assign. It's figuring out which one is 1/2 and which one is square root of 3 over 2 that is the most complicated. Now note, I put these values in order from smallest to biggest on purpose, because the way I figure out which value is 1/2 versus radical 3 over 2, I use that idea of which one is bigger versus which one is smaller. Okay, and here's how I do it. I draw a triangle to the angle. Now on this triangle, this side right here on the x-axis represents the x value. And this side right here on this right triangle is the y value, and it is a right triangle. Okay, so based on this drawing, the side that is longer is the x-axis, the side on the x or the x-coordinate. Therefore, the x-coordinate takes on radical 3 over 2. The y value is the smallest here, so it takes on 1/2. So I'm literally assigning it based on how long the side of the right triangle is for the x value versus the y value. Okay, let me do that up here at the 60-degree angle or pi thirds. So drawing that right triangle right here, in this case, the side that's on the x-axis is definitely shorter than the side that's on the y-axis. Therefore, the x-axis takes on the value 1/2 because it's the smaller number, and the y value takes on square root of 3 over 2. And that is how I know the first quadrant. I literally use triangles to help me figure it out. I've kind of memorized the middle point is radical 2 over 2, and like that's it. Like the other two, I just base it on size of the side of the triangles. Okay, so how does this extend into other quadrants? Well, let's take an angle and find the values of that angle. Actually, here, let me give a specific trig function I want to find. Let's say I want to find the sine of 210 degrees. All right, here we go. So we're in degrees. That's a little bit easier to work with. 210 is bigger than 180. So it's going to land in the third quadrant. Cool. Okay, so how much bigger is it from 180? That's my question. So I'm going to take 210 minus 180, and that gives me 30 degrees. So it's 30 degrees bigger than 180. And 30 degrees happens to be my reference angle. And therefore, I'm going to use that angle to help me base it off of how big it should be coming off of the x-axis. So 30 degrees is pretty close to the x-axis, okay? Like the 30 degrees is up here in the first quadrant, right? It's the one that's closest to the x-axis. So the way I've kind of drawn it almost looks like it's 45 degrees. Let me fix that. Let me go ahead and make it a little bit smaller. I mean, it is a little smaller, but ooh, pretend it hit the middle. Okay, I just don't feel like redrawing it. There we go. Okay, 30 degrees. Great. So it's the smallest one. Okay, cool. So I draw it like that on purpose so that I can visualize my triangle. And here we go. So on this triangle, the long side is on the x-axis, short side is on the y-axis. So therefore, the x value is going to be radical 3 over 2. The y value is going to be 1/2 because radical 3 over 2 is bigger than 1/2. Now, because it's in the third quadrant, both of these values are negative. And because I want to find sine, sine is associated to the y value. So the answer is negative 1/2. All right, let's try it again. That's how I do it. I literally figure out the rectangle, the reference angle, and base it on that. Okay. Really, I just understand how the first quadrant works really well, and it helps me with all the other quadrants. Okay, let's say I want to find the cosine of 5 pi over 3. Okay, so I need to figure out, first of all, which quadrant that's in. And I know that this is 0, pi halves, pi. Well, it's bigger than pi because 5 is bigger than the 3, okay? And then this is 3 pi over 2. So the question is it bigger than 3 pi over 2 or smaller than 3 pi over 2, okay? So the way I do that is I kind of think, all right, if I were to increase the numerator by 1, right, literally a +1, like in other words, make that 5 into a 6, what do I have? Well, I would have 6 pi over 3, which reduces to 2 pi. So it's very close to 2 pi. It's in fact pi thirds away from 2 pi, because if I increase, the numerator, this is pi thirds. Now notice how I forced the angle to be bigger away from the x-axis. That's because I'm imitating my knowledge of what happens in the first quadrant. Pi thirds of the 3 angles here in the middle is the furthest away from the x-axis. So I intentionally made the angle bigger. Okay, so if I am thinking of the unit circle here, then my rectangle is going to have the smallest side on the x-axis and its longest side for the y-axis or y value. So smallest value is the x, so it's a 1/2. Largest is the y, so it's a square root 3 over 2. Now, because it's in the fourth quadrant, the x value is positive, the y value is negative. Cosine is associated with the x value, so this comes out to positive 1/2. Oops, I said positive, and then I wrote a negative because I was looking at my other answer next to me and noticing that both of them happened to come out to 1/2. One was a negative, one was a positive. And there you go. Okay, that's how I figured it out. I based it on my knowledge of the reference angles, using that to help me figure out which quadrant it was in, and then using the lengths of the rectangle to help me do it. Okay, let's try another one. Let's say I want to find, we'll do a cosine again, the cosine of, I'll do another radian, 5 pi fourths. 5 pi fourths. All right, so here we go. Let me figure out which quadrant that's in. So it's bigger than 1, so it's going to be beyond the pi, right? It's going to be beyond quadrant 2. So it's either in third or fourth quadrant. If I were to increase the numerator by 1, that's going to become a 6 pi over 2. I'm sorry, 6 pi over 4, which reduces to 3 pi over 2. So it's in the third quadrant. It's in the third quadrant. And in fact, if I subtract pi from this, it comes out to pi fourths, which, by the way, the fact that it's over 4 tells me its reference angle is going to be pi fourths. It's going to be pi fourths, okay, because it's over 4. Cool. That's a nice thing to notice. So that's the reference angle, which means automatically, just because I understand how the first quadrant works, both the sine and the cosine are the same value, and it's that radical 2 over 2. Both of them are radical 2 over 2. And because both of them are in the third quadrant, both of them are negative. So this is going to be negative radical 2 over 2. I mean, honestly, I don't need the rectangle, the triangle to do this. The minute I know it's at pi fourths or 45 degrees, I know it's a radical 2 over 2. I just have to figure out what the sign is. All right, let's try another one. Let's say I want to find, how about, let's do tangent of 120 degrees. Okay, 120 degrees. So that's beyond 90 degrees, but less than 180 degrees. So it's in quadrant 2. Okay, so 120 degrees, second quadrant. Okay, the question I want to kind of figure out is where is it relative to the x-axis? Since this is 180 degrees, right? That's the x-axis there. That means it's 60 degrees less. So I want to make a big angle with the x-axis. And I'm going to draw my triangle. Okay, small side is on the x-axis. The large side is going for the y-axis in the y direction, right? It's the vertical line. So therefore, the x value is 1/2. The y value is square root 3 over 2. Because it's in the second quadrant, the x value is negative, but the y value is positive. Okay, but tangent happens to be sine over cosine. So I need to calculate what the sine value is over the cosine value. Scooch my screen over here. So that would be the square root of 3 over 2, that's the sine value, over negative 1/2. And then because I'm working with fractions, I can flip that division, change it to multiplication. The 2's will cancel. And I'm left with negative square root 3. And there's my tangent value at 120 degrees. And that is how I remember these. I don't actually have them all memorized. I literally think of a triangle or know that all of the pi fourths 45-degree angles are where they're equal, and then just understand what their signs are, like they're positive or negative, based on the quadrants. That is how I have memorized the unit circle my entire life.